Hi Science 10 students. So today is your first day of chemistry and we're going to go from there with your pre-lessons. So what I have notes for right now applies to this right here, your Science 10 notes package. So you'll need to open up your notes to that. Notice there's also a Word file that I put on Teams for you. You can use that file or you can print it off and fill it in, whatever you want. Just a reminder, you don't need to hand me your notes packages. The purpose of them is for you to get your learning pieces out of them and fill them in as you go, fill them in as I'm teaching you material. Do whatever you want with them. We're looking today at an introduction to chemistry, so a lot of this is information you'll have learned in years up till now. Maybe you're going to be revisiting some of this. Pause the video whenever you want, obviously, and you can write down some of the notes that I've already put up on the board here. So let's go with some of these key concepts. Your definitions I gave. If you look in a textbook, you're going to find definitions that are, maybe different in some small ways. But everything I put here is, I think, some of the most important understanding pieces you get from these topics. So what is an element? Well, an element is a pure substance, but not only just any pure substance, is one that's made of just one kind of atom. So, for example, we look at this fork right here. This fork is mostly made out of the element iron. In reality, it's a mixture of a number of different elements, otherwise it would just rust if it was only iron. But if it was pure iron, it would just be one kind of atom. It is a pure substance that is made of one kind of atom. In this case, you've got the iron atom. What is an atom? Well, an atom is a very small amount of any substance. And I mean really, really ridiculously small. It's impossible to actually visualize an atom with a camera because they're so small that the light rays, the waves of light, are actually longer than the atom itself. So we can come up with conceptual diagrams for what atoms look like, but you can't take a photo of them because they're just so absurdly small. But it is still, as a unit of matter, special because it's the smallest amount of matter you can have that you can identify as one particular kind of matter, as one element. You can't have a proton made of iron. The smallest possible amount of iron is an atom of iron. What is in an atom? Maybe best to shift over to here. This is the diagram on the second page that you see of your notes packages. So right here. What we've got right there is a diagram, again, for an atom. And the atom is a helium atom. We know it's a helium atom because of the number of protons. This is a way you can tell which atom is which, because every atom has only a certain number of protons in it. If you add another proton, it becomes a different chemical element because it's a different atom. If you look at this diagram, here we see in the middle, and in case you can't see far enough up there, I'm pointing at the middle of the atom, also called the nucleus, and we've got 4 balls inside there. 2 of them have a plus sign in them, 2 of them don't. The ones with the plus sign, we say they have a positive electrical charge. Those are protons. The ones that don't have a plus sign have no charge, no electrical charge. They're called neutrons. They're electrically neutral. Surrounding that, we have these very small particles, something like 1/1000th the size, the mass, of a proton. remember the protons are already ridiculously small, but an electron, in terms of its mass, if you could even weigh it, is about 1/1000th of the mass of a proton or of a neutron. Most of an atom is best described for you as empty space. But the mass, most of the mass of the atom is in the middle. One statistic you might hear a lot is that if you were to take an atom and consider where its mass is stored, it's mostly in the nucleus, but if you tried to find the nucleus, you might have a difficult time. If an atom were the size of a football field, the nucleus, where most of the mass is, would actually be only the size of an ant in the middle of the field, to give you kind of an idea of the size scale. So surrounding the nucleus, we have these electrons. One thing I'd like you to remember is that the electrons are in shells. I'd like you to remember that because that was a learning piece from Science 9. So we're going to be kind of revisiting that a little bit today. Something I would actually like you to do is maybe pause the video just now, and I'd like you to open up this page right here. The page is Dynamic Periodic Table. This is a very useful page because every page, every chemical element that is currently known is in here. You might also wish to get your textbooks. I think it's page 172 that has the periodic table on it. I might be wrong, of your Science 10 textbook. I'll note that later if I am wrong on that point. It's in the textbook in the chemistry unit. But also do look at the dynamic periodic table. I'm going to go through a few of the elements in there, or actually specifically the columns of elements in the periodic table. You might remember from Science 9 that the elements are grouped by their physical and chemical properties. The columns, each elements in each column have certain chemical and physical properties that you can predict. And you might also remember that it all comes down to the electrons. Before I get into that, I just want to remind you two other definitions I asked for. This is just a memory thing in general. That an ion is an atom with more or less electrons than it has protons. And, well, a noble gas. How about that? Maybe, by now, you have the dynamic periodic table open. Maybe you just have this in front of you. I would like you to remember, I'll remind you, where some of the elements are in this periodic table. For this notes, you're asked to identify the alkali metals, the halogens, to draw a line between the metals and the nonmetals, and then to find an element with a +2 ion charge. I think we'll actually do a little bit more of that, just more than that just now. First of all, these elements that I've circled right here, where I'm pointing, those are the alkali metals. Lithium, sodium, potassium, rubidium, cesium, and francium. They're special metals. They're a lot of fun because if you throw a piece of any alkali metal in water, there is a very big explosion, which is very entertaining to watch. Notice also, though, that I did not circle this element at the very top right here. That is the element hydrogen. It has some properties that are similar to an alkali metal, but it's a nonmetal. It's standard temperature and pressure. It's a gas. Notice also this. These elements here, again, where I'm pointing, those are the halogens. So we have alkali metals here, and the halogens are here. Halogens are, again, a lot of fun, but you would want to be very careful having fun with them because they are very nasty as well and explosive. They make strong acids. They react with just about anything else and form chemical compounds with them. Again, you might remember that this all comes down to the electrons. The alkaline metals have just one outer shell electron. This is science 9. Whereas the halogens are one short of having a full outer shell of electrons. Those are the halogens. Next to the halogens, here, column 18, this group right here that I'm pointing at, these are the noble gases. Noble gases, I described them right here. An element with a full valence electron shell that's chemically stable. So this includes helium, neon, argon, krypton, xenon, radon. Their shells are full. They don't need to have any other electrons to be given to them. They don't donate electrons to other elements, with some rare exceptions. They're chemically stable. So as a result of that, they're not involved in chemical reactions. So those are the noble gases. There's lots of metals with +2 ion charge. Hopefully you can identify those metals from the periodic table in your textbook that has ion charges. So that being said, there's many of them here in these elements right here in the middle, that big block of elements in the middle that I'm pointing out right here. They're called transition metals, and lots of those as ions can have a +2 charge. But there's only one group of metals that has all of them being a +2 ion charge, and that's the alkaline earth metals. Column 2. Beryllium, magnesium, calcium, strontium, barium, and radium, I guess. They are all alkaline earth metals, where I'm pointing right now. If you look on in your textbook, in your periodic table, you're going to see that. You're going to see that those metals, when they become ions, that is, when they become ions, you'll see they all have a +2 charge. And what does that mean? That means that they've given up 2 electrons. An electrically neutral calcium atom has got 20 protons and 20 electrons and some neutrons as well. When it's involved in a chemical reaction, it gets stability by getting the number of valence electrons or outer shell electrons as the nearest noble gas. Where is the nearest noble gas? Well, you're giving up an electron to get to potassium, but that's not enough. You have to give up another electron, and you get to the number of electrons in an argon atom. It gives up 2 electrons. When it does that, it then has the number of electrons in an argon atom. It's got what's called noble gas stability. It's losing electrons, 2 to get to that nearest noble gas. Beryllium loses 2 to get to the noble gas stability of helium. Magnesium loses 2 to get to the stability, the number of electrons, as neon. Calcium goes to argon. Strontium gets the noble gas stability of krypton. Again, they're all losing 2 electrons to make that happen. So, since they all lose just 2 electrons to make that happen, they get a +2 ion charge when that happens. Why the plus? Remember that electrons are negative. Protons are positive. You can't give away your protons. That just doesn't happen. In a chemical reaction, it's electrons that get given away or are taken by an atom, by one atom to another. So you get the positive charge by giving away electrons. Taking away in math, you know this, right? Taking away a negative makes you more positive. That's what's happening when the electrons are being given up. All of the elements in this group here the alkaline earth metals that I'm pointing at, they all get that +2 charge. It's very predictable in just the same way that all of the alkaline earth metals here, first column, get a +1 charge when they react chemically. The last learning piece from that first lesson was covalent compounds. Oh, actually, I forgot to say, between metals and nonmetals, where is that line? Well, actually, that's a bit misleading of me to put it that way, because it's not exactly a line between metals and nonmetals, since between metals and nonmetals, you actually have a group of elements. I'm going to circle them, and I'm going to name for you what they are. So boron, silicon, arsenic, antimony, and tellurium are all what are called metalloids. Let's look at the dynamic periodic table to see if there's more information about that. There's one other I need to add. If you look at the dynamic periodic table, you will see that it's pretty awesome because it color codes all the elements. In the periodic table, the dynamic periodic table, it will tell you that boron, silicon, germanium, arsenic, antimony, and tellurium are all metalloids. Let's find out about polonium. No, polonium is a metal, although it also tells us that astatine is a metalloid. No one's ever held a chunk of astatine because, well, it's extremely radioactive and there's only a few grams of it on Earth at any one time. But if you could, it would most likely be kind of dull, shiny, not super reactive, blackish in color. Not very exciting, really. Those are all the metalloids. So there's no firm line between metals and nonmetals. There's more a group of elements between metals and nonmetals called metalloids. So the one thing that you will notice is that it kind of works in a zigzag, a diagonal pattern. The elements that we have in this little corner of the periodic table, carbon, nitrogen, oxygen, phosphorus, fluorine, sulfur, chlorine, selenium, bromine, and iodine, all the elements in this little triangle right here, next to the noble gases, they're nonmetals. Noble gases are nonmetals too, but those particular nonmetals are very special because they can be involved in chemical reactions where they receive electrons, but also sharing electrons. That's all I want you to know for the pre-lesson 0.1 concept review. What I'm going to do next is I'm going to do 0.2.